In 1949, a man named Joseph Woodland sat in a chair on Miami Beach, doodling with his fingers in the sand. Woodland had quite a mind. He had worked on the Manhattan Project during World War II. Then, after the war, he continued his studies at Drexel in Philadelphia. And it was at Drexel where he caught wind of a local grocer who wanted a faster way to inventory and check out products. Woodland thought he had an answer: a machine-readable label for each item in the store. Enthralled with the idea, Woodland moved down to his grandfather's apartment in Miami Beach to develop it further. While there, he often sat on the oceanfront, pondering how he might make this theoretical solution a reality. He'd need a simple code for the label, something a machine more akin to a typewriter than a modern-day computer could read and log. Suddenly, he realized he already knew one: Morse code. So, he started drawing dots and dashes in the sand. This is the Lightbulb Moment, a Cheddar and Curiosity Stream original series, the show that uncovers the surprising impact of less celebrated inventions and the moments of inspiration that made them possible. The modern barcode faced constant challenges, overcoming decades of naysayers and failures before it finally took over our stores. These little sequences of black and white bars are everywhere. They've been part of the technological bedrock that has fueled the rise of everything, from massive companies like Walmart to world powers like China. Now, newly popular square barcodes are ushering barcode tech into our phones and allowing hundreds of times the information to be encoded in those little labels, opening up a whole new horizon of opportunities to link us to our digital world. That's where we're going, but it all started with those doodles in the sand in 1949. A strange turn of events had sparked that epiphany on Miami Beach. It began with a Philadelphia area grocery chain executive in the 1940s who'd simply had enough. Running his operation was a nightmare, and the problem was industry-wide.
You had people manually putting price stickers on products. You had people manually then hand keying those prices into a cash register and really spending time with every single product that a shopper was taking through the checkout.
That's Carrie Wilkie from GS1 US, the organization that coordinates and standardizes barcodes in the United States.
There was a lot of inefficiency and a lot of time spent for the consumers in the grocery store, really in the checkout lane, waiting to pay and exit the store.
So this supermarket executive visited a dean at Drexel and begged him to help engineer a solution to all his store's inefficiencies. The Drexel dean brushed the executive off, but one of the postgrads overheard the conversation and found it pretty interesting. The postgrad, Bob Silver, mentioned the conversation to one of his friends. That friend was Joseph Woodland. And together, the two thought maybe they could invent something to help the supermarket executive. This random game of telephone is what got Woodland to move down to Florida and start drawing dots and dashes in the sand on Miami Beach. But you probably wouldn't recognize what he ended up with.
The first early incarnation of a barcode was actually in a bullseye shape.
Woodland had enough foresight to realize that when store checkers would swipe items over the sensor, they would probably do so in all sorts of different orientations. Even if every label was fixed perfectly to, let's say, a can of soup, it might be upside down, horizontal, or vertical when the checker tried to swipe it. This created a problem because he was going to base his code design off of Morse code. And like the letters in a word, a Morse code-style design wouldn't be able to read from any angle. So Woodland solved this problem by expanding the dots and dashes into circular lines, which would make it omnidirectional. Or in other words, essentially copy that Morse-inspired code into an infinite number of orientations for the sensor. Looking down at his sketch and reveling in the prospect that he may have just invented something big, Woodland relayed the idea back to Bob Silver. Silver loved the idea, so much that the two got to work sketching out the mechanical schematics, finalizing their code design, and filing for a patent later that same year. Then, they began constructing a prototype, but soon realized the system wasn't quite working. The problem? This was all pretty advanced stuff. Theoretically, it made sense, but the actual available components hadn't caught up to the theory. It'd basically be like trying to build an iPhone with consumer computer parts from the 1980s. It just wasn't going to happen. Specifically, Woodland and Silver struggled with the light sensor. They couldn't find a bright enough light for the sensor to clearly interpret the code. They also lacked access to any modern computing technology to log the information that came out of the scanner. Woodland, hoping to get the help he needed to make the system work, soon took a job at IBM. But even that computing and electronics juggernaut couldn't provide the tech to get it off the ground. So Woodland shelved the idea. Almost 2 decades would pass before it saw the light of day again. By the late 1960s, it became clear that the grocery executive pleading with the Drexel dean years earlier was not alone. So the grocery industry got together to start talking about ways to harness technology to fix the inefficiencies in their stores.
They really needed something that was an intra-industry identifier that would uniquely say what was a can of beans versus a box of cereal so that they could move product more efficiently and move product more quickly and cut down costs and really cut down wait times for the consumers who were standing in line at grocery stores.
The chain Kroger helped kick off the industry's efforts in 1966, when it released a pamphlet soliciting help developing a scanning system from electronics companies. Their search led them to the Radio Corporation of America, or RCA.
RCA, the most trusted name in electronics.
RCA was an enormous electronics firm with a reputation that would rival Google or Amazon today. And just like these present-day tech giants, RCA was hungry to break into new markets. A dedicated group of RCA engineers and researchers took on the challenge. Soon, they found Woodland and Silver's patent, and RCA's team realized that with new advances in technology, they could make it work. 2 advances in particular changed the game. The first was the microchip. Invented in 1958, it set the groundwork for advanced, compact computing that could read, log, and interpret data from the scanner. The second was the laser. Invented in 1960, focused light and lasers would finally offer enough brightness for an electronic sensor to clearly and consistently read a printed code on a label. By 1972, RCA's team had created a working bullseye barcode system, ready for Kroger to test out in a real store. But Kroger worried customers might reject it. Lasers were mainly associated with advanced military applications. Kroger wondered if customers might fear a death ray, as it was popularly referred to in their supermarket aisle. Kroger also worried customers might not trust computers, which were still new, to read and tally prices correctly. Hoping for the best, Kroger went ahead with rolling out their new checkout system on July 3rd, 1972 in one of their Cincinnati stores. It was a success. The system worked. It scanned codes, it tallied checkouts, and sales at the Cincinnati store went up, suggesting customers actually liked it. A group of high-ranking industry representatives soon toured the store. Seeing the technology work, along with an increasingly urgent need to control costs as the industry's already slim profit margins dip below 1%, renewed the industry leader's commitment to scaling up the barcode. But while the bullseye code prototype worked in Kroger's one store, getting everyone in the industry on the same page was tough. It took months of negotiating and glad-handing. But after dozens of meetings and calls, the biggest players in both industries finally got behind the broad vision of putting a small label on every package. They would call it the Universal Product Code, or UPC. The one last thing to do was settle on the design of the standardized symbol itself. The code would need to be small and neat, a maximum of 1.5 square inches. It would need to be printable with existing technology, readable from any direction, and readable at speed, meaning from a swift swipe or scan. The grocery industry then accepted pitches based on these criteria from large electronics firms.
Looking at the proposals that came in, everybody thought that the RCA bullseye was going to be the symbol that was selected.
But then, one engineer at IBM flipped the script. That engineer was George Laurer. Laurer doubted Woodland's circular design could work at industry scale. The whole reason the code originally had a bullseye shape was to ensure it could be scanned from any angle.
The technology was really difficult, though. It was difficult to print it, it was time-consuming, it was expensive to print it, and the bullseye didn't lend itself to holding very much data.
Laurer was able to figure out, though, that a sequence of vertical bars could also be scanned from any angle. You just had to configure the laser a little differently.
What they discovered with the bars and spaces is they could put more information in a smaller space.
To prove to IBM's higher-ups that his more data-rich design was just as practical as the bullseye design, Laurer got an ace softball player to pitch beanbag ashtrays with barcodes fixed to them across the scanner. And as they whirled by, the scanner correctly logged each one's code. Suddenly sold on the idea, IBM's brass then pitched Laurer's redesign to the grocery industry. But something only IBM could offer, computing power, sealed the deal. As the story goes, the representative from IBM waited until the end of the pitch meeting. Then he pulled out a small, wafer-sized disk and said, "This wafer contains all the computing power necessary to run a checkout system." IBM had another ace in the hole too. Remember Joseph Woodland, who created the original bullseye design? And how he went to work for IBM in the 1950s when he couldn't get the technology off the ground himself? Well, Woodland was still at IBM in the 1970s, and even he endorsed Laurer's redesign. Woodland took that endorsement a step further when he went to meet with grocery industry representatives himself, reiterating how the RCA bullseye probably would hold less data, prove harder to print, and not fit as well on small items. Sure enough, the grocery industry ditched RCA's bullseye for IBM's vertical bar design. The world met the modern barcode in Troy, Ohio on June 26, 1974 at 8:01 a.m. in Marsh Supermarket. In a scene that would have looked much like this. A man named Clyde Dawson approached the register with a pack of Wrigley's gum. Sharon Buchanan, a 31-year-old cashier, swiped the gum's barcode into her new high-tech checkout system. And with that 67-cent purchase, a small-town supermarket thrust the global economy into a new era. But the grocery industry had no idea the barcode would become so prolific.
The thought was that they would assign maybe a couple of thousand identifiers, somewhere between 7 and 11 digits. They would close up shop and they would be done.
They were actually just getting started.
Once industries saw the efficiencies that we were gaining in grocery, there was a lot of interest to move beyond grocery and use the barcode in other ways. The barcode was really doing what it set out to do. It was increasing efficiency in the distribution network, and it was really increasing efficiency for consumers. So we were seeing far shorter checkout lines and far shorter wait times in grocery stores.
Then there were the new big box stores. By the 1970s, companies like Kmart, Target, and Walmart had become a favorite new place to shop for Americans. As these companies grew into billion-dollar operations, they started using barcodes, allowing them to keep track of an ever greater number of goods on their vast store floors. Walmart in particular can credit much of its success to the barcode. The company had an aggressive expansion strategy. It helped fuel that expansion with an advanced logistics network, the sprawling collection of warehouses, trucks, shipping contracts, and tracking systems that moved goods from suppliers' factories to store shelves for consumers. By the time Walmart became America's largest retailer in 1990, they had built much of that logistics network around the barcode. For Walmart, the barcode's value was in mapping where, when, and how everything moved through their stores. For any item, Walmart could see precisely what day and time it was sold. The company even obtained its own supercomputer to crunch the data. This helped them nail down consumer habits, figure out when product surges were likely to happen, and to organize supply chains so fewer goods sat unused in warehouses. The data also helped give Walmart the upper hand with suppliers, allowing them to bargain for lower and lower prices. As China began to open up its economy in the 1980s, this pressure for lower prices helped push Walmart suppliers to contract cheap, overseas labor. And soon, Walmart began cutting out the middleman altogether, setting up its own offices in China to teach manufacturers there how to integrate directly into their supply chain. As more and more major companies did the same thing, China's economy boomed, helping it grow from a centrally planned communist economy to the world's second largest economy today. The barcode was spreading around the rest of the world too. And now it's an essential, though understated, part of our lives.
It always blows my mind when we hear the stat that barcodes are scanned 6 billion times a day. I think we don't realize how often we interact with it. And it's not just interacting with barcodes that maybe we're scanning in the grocery store, it's the barcodes that are scanned in the postal service and in mail delivery and package delivery. It's barcodes that are being scanned in warehouse settings, surgical settings on medical products and pharmacies all around the world.
But even as the barcode has become so ubiquitous, it's changing. The standard barcodes we all have seen are one-dimensional barcodes. You might think that sounds crazy, but it's true.
All barcodes are not two-dimensional. The UPC that we are all familiar with really only goes on the horizontal axis, so it's one-dimensional.
In other words, the coded information is only in the width of the lines. The height is just there to make sure the scanner can catch the code as it swipes by. Those bars could be half as tall, twice as tall, or 100 feet tall, and they would still hold the same information. More recently, though, 2D barcodes have emerged.
Two-dimensional barcodes are typically square, sometimes rectangular, but they use squares and dots and other shapes to make up the information that's in the barcode, and they do that on both the horizontal and the vertical axis.
These include the QR codes you might scan with your phone and the strange-looking pixelated designs on UPS labels. 1D barcodes usually hold 12 digits and 0 letters. 2D barcodes can hold more than 7,000 digits and 4,000 letters.
We can put a URL, we can put more granular information about a product, and then we can allow the manufacturer of that product to really engage with the consumer in a much deeper and more meaningful way than they can in the product package.
This opens up huge new possibilities for the amount and kind of data that barcodes can hold.
Especially when we think about food, when we're looking for more information maybe about allergens or bioengineered products or things that are sustainable or recyclable or fair trade. There's so much information as consumers that we want to know about our products that simply won't fit on product packaging.
Beyond shopping, QR codes also let people do everything from accessing subway maps to finding their friends on Venmo. Then there's other forms of identifiers emerging, or as Carrie calls them, information carriers that are totally different than the barcode.
There are projects right now that are looking at embedding identification in recyclable materials so that they can be automatically sorted in a recycling center and increase efficiency in recycling. And that's all through identification. But those are things that are actually embedded in the substrate, so embedded maybe in the plastic that's in a bottle that we're using.
There's also RFID tags in use now, kind of like a toll pass transponder in your car that scan automatically as they move through supply chains.
We often say the UPC has been around for 40 plus years. It is not going away, but I don't think we'll ever have another data carrier or barcode symbol that lasts for over 40 years.
So as we look back on the evolution of the barcode, we can see the many strange twists and turns a revolutionary technology can take before it actually gets a chance to change our lives. In a sense, that invention has been the result of not just one light bulb moment, but many. From that 1940s grocer with enough imagination to dream of a world with automatic inventorying and checkout systems long before computers ever existed, to the post-grad Bob Silver who overheard the grocer suddenly realizing maybe a friend could help build that system. There was that moment on the beach where Joseph Woodland sketched the first barcode design into the sand. But now we can see it looked nothing like the barcode we have today. Then, even after RCA resurrected Joseph Woodland's concept and turned it into a working prototype in a real-life store, yet another light bulb moment transformed the clunky, hard-to-print bullseye symbol into the iconic white and black bars that we know today. From integrating that technology into Walmart supply chains to using it to coordinate global trade across the Pacific Ocean, little by little, we have seen bright minds build on one another to make the barcode a backbone of the modern economy. Now, we are seeing all sorts of new types of data carriers. And as we look ahead, only one thing is for sure. Woodland's sketch on Miami Beach has permanently changed the world.